So mean of a binomial distribution is going to be as follows. It's just going to be n times the success rate. The variance is going to be n times the success rate times 1 minus the success rate. So in our previous example, right, we had a n of 10, a success rate of 0.28. That's a 3. So the mean of this is going to be n times mu. So it's going to be 10 times 0.28, which gives us 2.8. And then the variance is going to be 10 times 2.8 or 0.28 times 1 minus 0.28, which gives us 2.016. There are tables that can help us with this kind of stuff. So we don't need to do this situation, right? There are binomial probability tables constructed for you in your book. So table 6-2 is going to have a bunch of different binomial probabilities for different values of n. So each table will have like a n equals 6. And then it's going to have a bunch of things about the probability. So for our particular example, or no, sorry, we have a new example that's about cell phones. So we are told that in the Southwest, 5% of all cell phone calls are dropped. And then we're asked, what's the probability that 1 out of 6 random calls are dropped? And then we're also asked, what's the probability of 0 out of 6, exactly 2, exactly 4, so on and so forth, right? So we can use some shortcuts here. So we have n equals 6. That's the total number that we have here, the 1 of the 6. We have a probability of 0.5%, so we find the 0.5% column on the table, and that's the one we're going to look at. And on the row axis, we have our x. So we have our pi on the column axis. We have our x on the row axis. And so if we are looking at 0 of them being dropped, the probability is going to be 735. If we're looking at 1 of them being dropped, the probability is going to be 232. So these are the values inside of the table 6-2. Also in appendix B, B.1.